This is a question from digital logic. We are asked to identify the code sequence, and this is the sequence given. And the four options are BCD, XS3, gray, and XS3 gray. So let's see how to solve it. First of all, let's understand the options that are given. First one is BCD. BCD, it actually stands for binary coded decimal. Binary coded decimal. It is a binary encoding of decimal numbers where each decimal digit is represented by a fixed number of binary bits. So it is usually a representation of 8421. That is, each binary bit is represented with 4 bits. So from 0 to 15, we can represent as it is. But beyond 15, what happens is for each of the decimal digit, we represent it in 4 bits. For example, 14 is represented as 1110. This is the BCD representation of 14. But 22, or assume 23. So here we'll split each digit as such. 3 will be represented in 4-bit as 0, 1, 0, 0, 1, 1, and 2 will be represented as 0, 0, 1, 0. This will be the representation of 23. So this represents 2 and this represents 3. So this is binary coded decimal. Next one is XS3. 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 In XS3, what happens is it is derived by adding 3 to each of the decimal digit and then representing the result in binary. So for the initial decimal number, we add 3 and then represent it in binary. So 0 is represented as 0 plus 3. It will be 3. 3 can be represented as 0, 1, 1. This will be 0. 1 will be what? 1 plus 3 is 4. So it will be 1, 0, 0. Similarly, in this fashion, XS3 will be represented. Ideally, we are adding to the decimal number plus 3 and then representing it in binary. This is XS3. Third one is gray code. So gray code is a binary numeral system where two consecutive numbers differ only in 1 bit. So two consecutive numbers differ by 1 bit, differ by 1 bit only. This property is useful in reducing errors in mechanical systems. And basically in gray code, how to convert a binary to a gray code. So assume we are having a number that is like 3. 3 is represented as 0, 1, 1. We can assume it like this. Or simply 1, 1. With 2 bits, we can represent 3. So what happens is the MSB bit will be kept as such. Then the MSB bit will be XORed with the second bit. So 1 XOR 1 will be 0. This will be the gray representation. For example, let's see another number that is 8. Or let's see 9. 1, 0, 0, 1. So what happens is we keep MSB bit as such, then we XOR these 2 bits to get the second bit. 1 XOR 0 is 1, then we XOR these 2 bits. So 0 XOR 0 is 0, then we XOR this bit. 0 XOR 1 is 1. This is 9 and this is the gray representation. These are the basic 3 numbering systems, and XS3 is not a standard numbering system. So this can be eliminated outrightly. Now, what is the solution? So from these 3, we can say that gray is the correct answer to this solution, and we'll explain how. So the sequence given below is actually gray code representation of 12, 13, 14, and 15. So 12, how can we represent it in binary format? 12 is 1, 1, 0, 0. So the gray code representation is what? We keep MSB bit as such, then we XOR these two. 1 XOR 1 is 0, then 1 XOR 1 is 0, then 1 XOR 0 is 1, 0 XOR 0 is 0. So we are getting this number. Now 13, 1, 1, 0, 1. So this will be 1, 0, 1, 1. 1 we keep as it is, 1 XOR 1, 0, 1 XOR 0, 1, 0 XOR 1, 1. So this is the second number. 14, 1, 1, 1, 0. We keep the MSB bit as such, 1 XOR 1, 0, 1 XOR 1, 0, 1 XOR 0, 1. Then this is 14. So here this is 12, 13, 14, and this is 15. 15 is 1, 1, 1, 1. We keep MSB as such, 1 XOR 1, 1 XOR 1, 1 XOR 1. All will be 0. So this is actually the gray code representation of 12 to 15. So based on the options, option 3 is the right choice.